lecturemth15571, learning about the world through surveys. This particular 7.1 will deal with distinguish between populations and samples, parameters and statistics, identify possible sources of bias in surveys, identify the features of a simple random sample. A population of a group is a group of objects or people we want to study. A parameter is a numerical value that characterizes some aspect of the population. It could be a height, could be a weight, some parameter, numerical value, something that we want to measure, meaning that we don't necessarily know what the measure might be. Population parameters. Data is gathered on all the heights of all NBA players. The mean of the data is calculated. The population here is the population of NBA players. The parameter is the mean height, what we wanted to measure. The census is a survey which measures every member of a population. Most populations are too large for a census, so we study populations by measuring samples instead. A sample is a collection of objects or people taken from the population of interest. So since populations are so large, to save money, they'll do a sample. It costs less money. A statistic is the result of a measurement from the sample, a particular characteristic of the sample. Because statistic is used to estimate the value of a population, sometimes it's called an estimator. So we look at a sample mean of heights to tell us something about the particular population height. Statistics, samples and statistics. Example, a researcher is interested in studying the heights of American women. She takes a random sample of 1,500 American women and finds the mean height in the sample to be 63.6 inches. In this case, the sample is 1,500 American women. So statistic is the sample mean. Assuming that here, the researcher may estimate the average American woman is 63.6 inches tall. Notice it says here random sample. Okay. Statistical inference. Statistical inference is the art and science of drawing conclusions about the population based on observing characteristics of samples. It involves uncertainty because the entire population is not being measured. An important component of statistical inference is measuring our uncertainty. So a lot of this here may have to do with how the sample is collected. If it's a large enough sample, if it's a representative sample, then you can make draw pretty good conclusions on that. The difficulty is here because populations are so large, and we can't study the entire population. There's a certain amount of uncertainty that goes on. We want to make sure that the sample is large enough to be representative, but not too large so that it costs too much money to contact everybody. Example here, GMOs, genetically modified foods. In 2015, the Pew Research Center published a report stating that 37% of Americans believe that genetically modified foods were safe to eat. This was based on a survey of 2002 American adults. Okay. Let's identify the population in the sample. What is the parameter of interest? What is the parameter of interest? What is the statistic? So when we look at this here, you see the population. the population, all American adults. And they did a sample. They did a survey of 2002 American adults. That was a sample. What were they interested in? What were they interested in? Parameter of interest, the percentage of Americans who believe that GMOs were safe to eat. That's what they were interested in. The actual statistic in here, what they were measuring, is 37%. So you can see that there. And there you see here. What they were measuring, the statistic is it's a number. What they were trying to study, the percentage of American adults. What were they looking at? They were trying to find out something about a population from a sample of 2002 American adults. Statistics versus parameters. Statistics are knowable. Anytime we collect data, we can find the value of statistic. Parameters are typically unknown. You can be estimated with statistics, but these estimates involve some degree of uncertainty, depending on how the data is collected. Too small a data set, too large a data set. Did I manipulate the data? Did I do a convenient sample and just ask my friends about it? Okay, but they would involve some degree of uncertainty here. In general, Greek characters are used to represent population parameters there. Population mean. English letters are used to represent statistics here. Population proportion. The percentage who like mac and cheese. It's a proportion. Bias. A survey method is biased if it has a tendency to produce an untrue value. 3 types of bias: measurement bias, sampling bias, and using an estimator that is biased. Measurement bias result from asking questions that do not produce a true answer. It occurs when measurements tend to record values larger or smaller than the true value. For example, here, asking people how much do you weigh, it's unlikely that people will report a true value for their actual height, resulting in an estimate that tends to be too small, all because of the way they ask the question. So a lot of work goes into producing surveys that actually can ask questions that can measure what they're looking for. Measurement bias can occur in a variety of situations: self-reporting of personal data, the use of confusing wording in a survey, the use of non-neutral language in questions. So, how do I say it? Code words make people think a certain thing, and they have a predisposition to a particular thing or object, and they'll vote a certain way. Another type of bias is sampling bias. When you use a sample that's not representative of the population, that would be something like if I stood outside of a McDonald's and asked them if they like Burger King. Okay. Or if I stood at the foot of a pier and asked people how I felt about raising the taxes on the slips on the pier, on those spots. They have strong feelings about the results and aren't necessarily representative of the population. Important questions to ask about sampling. Uh, what percentage of the people were asked actually did so? Uh, did researchers choose people who to participate in the survey, or did the people themselves choose to participate? So you can actually have things going on there. If a large percentage of people, if those chosen to participate, refuse to do so, or if the people themselves that chose to participate, the conclusions are suspect. Because you can have a situation um, on a particular hot topic, something like uh, abortion or AIDS or something, and people might not want to respond to it. So you may end up with too small a sample to draw a conclusion from. Or you might have a situation where people want to give you their opinion on the survey, so you end up with people who feel strongly from the beginning about a particular topic on a survey. So it's not going to be the conclusion is going to be suspect and not representative of the entire population. A lot of identifying bias goes into the design of the particular study. School district is interested in finding out what percentage of voters in the district would favor the passage of a school bond measure. The district sends out a survey to all school parents. Do you favor the passing of a school bond measure to provide additional uh, resources to improve your educational opportunities for your student? So the problem with the statement here is that, do you favor? It doesn't ask about how it doesn't ask from a neutral. It doesn't ask the question in a neutral way. So it's just like saying, "Are you against busing?" Asking a question like that gives them a predisposition. So, yeah, I'm against it, or no, I'm for it. It doesn't give a lot of room. Use of non-neutral language in the wording here. It kind of like plants the seed of a particular uh, predisposition. It plants the seed for how to feel about a particular topic, and it can shape the survey. So it can introduce possible measurement bias into the survey. So you can ask questions in such a way that about abortion, for example, that may actually plant the seeds to make the person pro-abortion or con-abortion, all from the way you ask the questions in the survey. And people pay good money for good surveys because there's lots of $1 million that could be spent based on statistics. So to get rid of a lot of that, they do something called simple random sampling. Draw subjects at random from the population without replacement. Random sample is one in which every member of the population is equally likely to be chosen from the sample. A true random sample is difficult to achieve. Uh, Statisticians have developed methods for producing random samples that can be used. You can have a random sample and it not be representative of the population. You can have a random sample and it's random, but it's a bad sample. It's not representative of the population. Uh, one fix with that is some statisticians would do something called a stratified random sample, where they actually pick uh, people from different parts of society or different age groups, for example, some young, some middle aged, and some old, and they get random pick from the randomly from there. So and each sample is going to have some old and some middle aged and some young, but they're all randomly picked. So they make sure it's representative and it is random. It costs. It takes a little more time to do, but you get a good sample there. And that's the end of that one there.